All right, we're going to start section 7.2, adding and subtracting, rational expressions. We're going to start off with this concept of, actually, let me back up a second. Adding and subtracting rational expressions, sort of an extension of what we did yesterday in 7.1. 7.1, we did multiplying and dividing, so rational expressions. So now we're going to take and add and subtract them. And before we do that, we need to understand this concept of least common multiple. All right, so to find the least common multiple of a set of terms, what we're kind of asking ourselves each time is, what is the highest power of each multiple, okay? And the easiest way to demonstrate this, I think, is just by looking at an example and seeing kind of how it breaks down. So let's go to number 1 here. We want to find the LCM, the least common multiple, of 6xy, 15x squared, and 9xy to the 4th. What we're going to do first is, as we're trying to build the LCM here, is we'll look at numbers. So let's see, let's just write this over here. So LCM, that's going to be equal to, and we're going to kind of fill it in as we go. So I'm going to first look at the numbers, the coefficients here on each term. First one is 6, and then I'm going to factor it. So this is going to break into 2 times 3. All right. Then I'm going to look at 15. I'm going to factor that. 15 breaks into 3 times 5. And then I'm going to look at 9. 9 breaks into 3 times 3. And then any repeated factor, just raise it to the correct power. So this is going to be 3 squared. Okay. So then I go through each number, and I find the highest power of each factor between all of the factors. So I have 2 to the 1, and there's no other 2's. So the highest power of 2 is 2 to the 1. So there's got to be a 2 in the LCM, 2 to the 1 power in the LCM. Then I look at 3's. I have 3 to the 1, 3 to the 1, and 3 squared. I'm going to take that 3 squared. That's going to be the highest power of 3 that shows up. And then I have 1, 5. It's 5 to the 1 power. So I'm going to put that into the LCM as well, 5 to the 1. Okay? And that will always work. Factor completely, group by highest, or group by powers or exponents, and then find the highest of each one. Okay, so there's your LCM for the coefficients. Then we do the same thing with the with the variables. The variables are easier because you don't have to do any work. You just look at them. So we have x to the 1 power, x to the 2, and x to the 1. All right, so highest power of x is to the second power, to the 2. And then we look at y's. We have y to the 1, y to the 0, I guess, and then y to the 4th. So we have y to the 4th is the highest power of y. All right, and then just simplify the numbers. So we have 2 times 9 times 5. That turns out to be 90. So 90 x squared y to the 4th. There. There are other ways to approach it that might be a little bit quicker, but honestly, that's the surefire way to kind of always end up at the correct LCM. It does take a little bit longer than just kind of looking at it and noticing that 90 is the number, but I think it will usually, or I think it will always work. Okay, now sometimes factoring, so notice here we took the numbers and we factored, right? We're going to do the same thing over here. So to find the LCM in these two polynomial expressions, I'm going to have to factor. So this second term, or this second expression here, factors just like any quadratic would. You can use the magic X or guess and check or whatever. In fact, let's just start with that one. So this is going to break into y and y. Numbers that multiply to give you negative 40 but combine to give you 3. That's going to be minus 8 and positive 5. And again, you can use the magic X on that if you want. And there's your factor there. There was no monomial to factor out first, so we could just jump right to factoring. Here, I check for a monomial, and there is going to be one. So I have y to the 4th, y cubed, and y to the 2nd. I can factor out a y to the 2nd out of each term. In other words, I can undistribute a y to the 2nd. All right, and so if I do that, this is what I get. I'll get y squared times y squared plus 8y plus 15. And then this piece right here, I can factor that quadratic. So I get this, y squared. And then it will break into, what is this going to be? Numbers that multiply to give you 15 and combine to give you 8. So that's going to be 5. So we have y plus 5 and y plus 3. Okay? So I've completely factored this expression. I've completely factored this expression. Now I can write my LCM. Not very good spacing management here. So I have LCM it will be the highest power of each factor. So the highest power of y is y squared. The highest power of y plus 5. Well, there's a y plus 5 to the 1 power here and to the 1 power here, so that's just going to be y plus 5. Then the highest power of y plus 3. Well, there's y plus 3 to the 1, and that's it, so we got to include that. Highest power of y minus 8. Well, there's y minus 8 to the 1. There's only one of those, so it's y minus 8. And that's it. That's our LCM. So that one's, we sort of had to take every factor to get that one, but that's it. Okay, now we're going to sort of shift gears. The LCM is going to be the way that we add and subtract rational expressions. We're going to need the LCM to do that. But let's start with just kind of adding regular fractions with numbers here first before we get too carried away with actual full-out rational expressions. Okay, so here's how I teach how to add fractions. All right, what you want is the denominators to be the same. Okay, think of it like this: if you divide two pizzas up into thirds, and then you combine, let's say, 2/3 of actually let's do this. Let's divide the pizzas into fifths, and so you take 2/5 of one pizza and you add that to the 2/5 from the other. How much pizza do you have? Well, you have 4/5 of a pizza. Okay, so the denominator being the same means that you only need to worry about adding the parts of the pizzas. Okay, so common denominators makes adding and subtracting fractions very easy. And so right here in this first example, the denominators are not the same. What I have is 5/6 plus 1/3, and 5/6. If I were to break down 6, it would look like this. So let's write it a little bit bigger. So 6 would break into 2 times 3, okay, plus 1/3. And so what I notice is that each one of these fractions has a factor of 3, but this one is missing a factor of 2. So I'm going to give it a factor of 2. I'm going to multiply it by 2, but I can't just go multiplying by 2 whenever I want to make the math nice. I have to multiply both the top and the bottom by 2 because effectively I'm multiplying by 1, 2/2, but I've written 1 very carefully so that it's helpful. Okay, so then when I add these, when I make the next step, it's going to look like this. It'll be 5/6 plus, this will be 2/6, because remember we're multiplying fractions here, so it'll be plus 2/6. And if I do that, then I get 7/6. Notice the common denominator, I can just add the numerators. Okay, we're going to do that same thing on this one, except for subtraction. It'd be a good spot to stop right here and pay attention, stop and try this one, and then play it and see how it goes. So I'll go through this one a little bit quicker. If I'm taking 9/10, I'm just going to rewrite that real quick as 9/2 times 5 minus 5/2 times 3. And then I check the denominators. I see that each one has a factor of 2. That's fantastic. This one is missing a factor of 5, though, so I'm going to give it a factor of 5, but I have to multiply by the top and the bottom. And this one over here is missing a factor of 3, so I need to give it a 3, but I have to multiply it by the top and the bottom. And this number down here, so 6 in this example, and this would be 30 in this example, this number in the denominator is the lowest common multiple. That is the LCM. So I don't use the term LCM too much. I usually just look at it in this way, which is let's make the denominators the same. But that's what I'm getting in the denominator is the LCM. All right, so finishing this out, I have 3 times 9 on top, that's 27, over, this is, let's see, 6 times 5 is 30, so over 30. Minus 5 times 5, which is 25, over 30. And then I can take 27 minus 25, that's just 2/30. And if you were to simplify that, you end up with 1/15. Okay. All right, so that's how you do that one. Now let's level this up into polynomial expressions now. So here I have common denominators already, so I can just add the expressions. This will just be 3x plus 7 over 5y squared. Nothing else to do there. In this one, I don't have common denominators. I notice that there's a factor of x plus 6 here, but there's a factor of x in this one. So this expression here needs a factor of x, so I'll give it a factor of x, but I have to multiply the top and the bottom by x. When I do that, I get this, 3x on top over x plus 6 times x. And then over here, I have 7x plus 2 over x plus 6 times x. I didn't need parentheses around that, but these are the same denominators. So now I can just add across the top and the bottom. So I get 3x plus 7x plus 2. I'm sorry, not adding the bottom. The common denominator just shows up down here. So I just have x times x plus 6. Very similar to up here when we added fifths, the denominator was still 5. You don't add the denominators. You just get this, and then you simplify the top. 3x plus 7x is just 10x plus 2. So I get 10x plus 2 over x times x plus 6. Next one. Now that one was nice, we didn't have to factor anything, but this one we need to factor, okay, in order to figure out what we need to multiply by. Very similar to when we had numbers, we had to factor 6 to notice that we needed to multiply by 2 to make the denominators the same. So I'm going to factor x squared minus 36. That is going to factor into, so let's see, minus 3 on top, x minus 6 and x plus 6. And this is going to be plus 4 over x plus 6. And what I notice right away is that this fraction here has an x plus 6 but is missing an x minus 6. So I will multiply by x minus 6 over x minus 6 here. Now that I have a common denominator, I can add the fractions. So I have negative 3 plus 4 times x minus 6, all divided by x minus 6, x plus 6. Warning, sometimes students will see this x minus 6 over x minus 6 and they just can't help themselves. They try and cancel that out. No, because we have this addition sign right here. So these terms are not being multiplied, so we cannot simplify the x minus 6 over the x minus 6. All right, you should probably clean up the top. So simplifying the top just would be adding like term, distributing the 4 and adding like terms. So when you do that, you end up with this 4x minus 27, all divided by x minus 6, x plus 6. Excuse me. Okay, last problem. Guess I can't make that go. Okay, got the camera right now. So same kind of thing here. We're going to have to factor the top and the bottom, or sorry, factor each fraction first, and we're going to be sort of careful while we do this. So 6x minus 18. I noticed that I can factor a 6 out of both the 6 and the 18. So I get this 5 over 6 times x minus 3 plus still have the x minus 1 on top, so we'll leave that there. And then I need to factor the denominator, this 4x squared minus 14 plus 6. Always check for a monomial first, and I noticed that there's a factor of 2 in every number here. So I'll take that 2 out in front. So I'll have 2 times, this will be 2x squared minus 7x plus 3. All right, and then we need to factor this 2x squared minus 7x plus 3. Let's do the magic x on that real quick. 2 times 3, that's AC, so that gives me 6 here. Negative 7 for B. Numbers that multiply to give me 6 and combine to give me negative 7. That's going to be 6 and 1, as long as I put a negative on the 6 and a negative on the 1. So I have negative 1 and negative 6. And then the last step is to divide by A. So I divide by 2 here and 2 here. So I have negative 1/2 and negative 3. And then remember that if you have a fraction, so I'll write this out down here. So if I have x minus 1/2 as a factor, I kick the 2 out in front of it, and that factor is actually 2x minus 1. Okay, so that's how this breaks up. It's going to be 5 over 6 times x minus 3 plus x minus 1 divided by 2 times x minus 3 times 2x minus 1. Make the denominators match now. I notice that this has a 6, and this only has a 2. It needs a factor of 3, so I'll multiply by 3 over 3. And then I notice that this one has an x minus 3, as is this one, And this one has a 2x minus 1, but this one doesn't. So I'll multiply by 2x minus 1, top and bottom. All right, let's move up here so that we don't make things too confusing. So here I have 5 times 2x minus 1 plus x minus 1 times 3, right? 3 times x minus 1 needs to be up there. So plus 3 times x minus 1. That's all going to be divided by the common denominator, which is going to be 3 times 2 is 6, so it's going to be 6, x minus 3, 2x minus 1. I just did that in one step, and that's fine. You don't need to do you don't need to write those separately and then combine them if you want to just jump ahead. Okay, so then you're going to do some math on the numerator just to simplify it, and you'll end up with your final answer, which is 7x minus 4 over 6 times x minus 3 times 2x minus 1. Right? So there's a lot kind of bundled into this section. There's factoring, there's lowest common multiple, there's making the denominators match, and then finally adding the fractions together. Make sure that you ask me questions as they come up, but that pretty much wraps up section 7.2.